Hi, this set of notes goes over free fall. We'll just take a look at some basic ideas. First, ask yourself, is these things the same or different? Are these free fall or not? Is a dropped tennis ball free fall or not? Is a ball thrown up in the air free fall or not? What about if you throw the ball through the air to another person? Is that free fall? What about dropping just a plain piece of paper versus a crumpled up piece of paper? What about if you shoot like a rock from a catapult up at an angle so it arcs through the air? Is that free fall? What about a person jumping up and down? All of these, you should be asking yourself, are these free fall? Okay, because how we define free fall lets you answer these questions. So what is free fall? Now, within everything that we know so far, we can say that free fall is any motion in which an object is only under the influence of gravity. All right. So basically, it's this thing that's pulling us down. Basically, nothing else is touching the object. That part right there. Okay, this part right here. That is the important part. All right. The qualifications of this are that for it to qualify, it must be negligible air resistance. There must be some aspect of the motion that is vertical, and the acceleration must be constant and caused by gravity. And we'll talk about what gravity is in a later unit. Like, how do we get gravity? It's kind of the force of gravity. We'll talk about that in a later unit, so spoilers. But you need to know the acceleration itself is constant. So important, free fall is when nothing else is touching the object. And our constraints are 1, negligible air resistance, mostly vertical, at least some motion is vertical, and that the acceleration is constant. Okay, so now that acceleration that is due to gravity, all right, okay, we call that AY or G. And so now that we're moving, AY comes from the fact that we are now moving vertically as well as horizontally. So we say AY to indicate that vertical motion, or use little g. Do not use capital G, that means something else. And the value of it depends on your location in the universe. Okay, on Earth, everywhere on Earth, the value of gravity is 9.8 meters per second. And for every object on Earth, that is 9.8 meters per second downward, because if we're on Earth, we're being pulled down. What this means is that every second, an object's speed increases by 9.8 meters per second. All right. Okay, maybe it's better to say an object's speed changes by, I won't say increases, probably better to say that changes by negative 9.8 meters per second. So that could be an increase or a decrease depending on which way it's going. Here's another way of looking at it. We'll use the negative 9.8 meters per second squared when we are talking about things that are happening in real life, like real labs. But we'll also allow ourselves to use 10 meters per second squared when we're dealing with just problems, just for the sake of it. Now, please note that there is no direction on this one. All right. That's because free fall, the direction only comes in relation to something that you're talking about. So the value of gravity, of acceleration due to gravity, is 9.8 meters per second squared. You put the sign on it based on whether or not that 9.8 meters per second squared is pulling you one way or pulling you another way, whatever the direction is. Here on the left, you can see an object dropped with the dot diagrams. You can see how that looks. You can see the acceleration. It's getting further and further as time goes on. How would we look at that over here? So we start at 0. You find out that at 1 second, you're going 10 meters per second. 2 seconds, you'd be going 20 meters per second. 3 would be 30, 4 would 40. So basically, however long it's in the air, 10 times that is how fast it's going. Remember, our acceleration is the change in velocity over the time interval, and the acceleration due to gravity is 10 meters per second.